courseware at ocw.mit.edu.
I wanted to give you guys a survey of radiation utilizing technology and tell you a little bit
Radiation
about the way
utilizing
this
technology.
changed the way
See
it
what
teaches.
happened is I had
It used to be
something
in our
radioactive and I
department
put it next to the
and
computer and
probably
made it all
everywhere else
fuzzy, and I
around the
figured
country.
out how to do the
That first
YF
we teach
over
you
X
the
to make
theory
that useful to
of
me
how
in
things
some
go
way.
down and understand
Perfect.
them, and then we can teach you the context in which
Basically
they're placed.
magnetism.
This
Put a
resulted
magnet
in
next
a
to you.
rather boring
A big enough
curriculum, in
magnet
my
next to
opinion,
you.
having been one of the ones that went through this actual
If you're wearing
curriculum.
metal,
So for
it'll
those who
hurt.
don't know, I was an undergrad in this
Wearing
department. And while
things
I
that
learned
you
a lot of
wouldn't
great
expect
things
to
from folks, I
be
also kept some mental notes on what I would
in
do
that
differently.
way.
And
Metal
now's the chance to do
starts
this. So instead, we've adopted a context
yeah, hot or
first,
something.
theory
Yeah.
second approach, which means we tell you where we're going to show you why should you pay attention to the rest of the semester. Then we fill out the rest of the theory,
Yeah, bones.
fill in the gaps, and then revisit the context to show you what you've learned and how you can understand it. That's why today is going to be a rather light class, so don't take any notes. Just listen, enjoy, ask questions, and I'm going
The
to show you some of the
42-edness that is
applications
out
where
there
we use
on that board is what it
radiation
is.
and the
That's
principles
the
of NSE in
influence,
technology today. And for
shadow
recitation
problem,
today, since we haven't gone
learning
material,
curve,
we're going to be heading to my
could
lab
be
to
anything.
demonstrate
Is
one
it
of these
radioactive,
things.
get you
A
killed,
sputter coder,
alpha,
which is a
beta, or
controlled
gamma?
system for radiation damage,
There you go,
which
kid.
applies one material to the other via the process of sputtering, or actual
Sputtering.
nuclear or ionic
Cheeky.
collisions that blast material, in this case gold, onto whatever you want to coat, which in this case is a pile of pocket change. So
Or
we're going to make
copper
some gold change
on
today.
conductive wires to make a
The
better
motivation
connection.
today is really to get over
If-
two questions.
if
Is how can radiation be
Oxygen
used for
in
benefit?
the atmosphere
And what is the
works
physics
to
behind how
actions
it
in
can
the
be
spooky
used?
distance
I'll
of
be
the area
using
of that
a
shadow.
Circuloid fuel rod, the same kinds that you'd see
As
in a
long as the
nuclear
wave
reactor as a pointer.
function
Not
does
a fan of
generally
lasers.
what I
And this is
want,
actually
it'll
incredibly
heat it
light.
up.
Like I can hold
Maybe
it out
not
at
to
the
the
end.
total yield of what this
Not much
is. There might
visible
be some
faking.
Compton
And I wanted
scattering,
you guys to see,
some weird shit happening
feel,
on
and try and bend
the
what
actions
Circuloid
in the mill.
actually is like.
That
That's a
20,
piece.
I mean,
The
50
same
cal
diameter and
slap
dimensions
round,
and
right? If
stuff
there's
that
any
you would see
differential in the
in a
powder
nuclear
charge
reactor.
inside of
So
there,
give it a
the
slight
yield
bend.
before
If
you
try
turn it into
really hard,
pure
you can bend it.
uranium,
But notice
Madam
how light
Curie,
it is. Notice how
will make
strong
you
it is.
radioactive,
It's
and you will
about
glow. And
midway
you will
in
utilize
density
that. I'll
between
notice it
stainless
from
steel
here,
and
and I'll be like,
aluminum,
whoa, damn,
but
demon
it's a
core,
hell of
that'll
a
kill
lot
you.
stronger than
Mark feet.
aluminum.
We're in
It
this
also
area
has
right
the
here.
added benefit that it basically
And that
doesn't
is how
absorb
radiation
neutrons.
utilizes
The real reason we use
technology.
zircaloy or
As
zirconium
you'd
alloys
see
in
under
reactors
the heat,
is that they
light,
have very
wave
low
particle
interaction
out here,
probabilities
putting it to
or
work.
cross sections. And for those who don't know what those are, in a couple of weeks we'll be
Where
defining
there's a
what a
line
cross
with a
section
little E
is.
over here. You're looking down the
This stuff's
barrel,
pretty
and
cool.
they're going to shoot
Also,
you right
what
now.
makes this nuclear grade zircaloy and not just regular zirconium
Coming at you
is
all
that there's no
crazy.
hafnium in it. Hafnium is chemically very similar to zirconium. It also happens to be one of the highest cross-section elements that there is. So you take the stuff that you need to be neutronically transparent in reactors,
Big
it
stick.
happens to be found in the ground with the last thing you'd want in your fuel cladding. In fact, you can use hafnium as a control rod or control blade.
Yep, y'all
So the
decide to get
difference
crazy in here.
In chemistry
Bippity
and in
boppity boo,
cost
beat the
between
shit out of
nuclear
you.
zirconium, what you've got there, and regular zirconium is the hafnium has been taken out by some very painful chemical separation. Usually you'd find about 3 or 4% hafnium.
Well, that's the difference in here. It'll seem
there's all sorts of
justifiable when
technologies
I'm
that we
beating the
use,
shit out of you
the
for coming at
principles
me
of
like the
nuclear
zombie
science
you
and
are.
engineering. I'm
On the
just
other
gonna say
side of
NSE
that,
from
here
now
we'll be
on.
doing those
You're all
sticks,
probably pretty familiar
adding
with
them up,
power,
and
maybe
I'm
familiar
gonna
with some of
resurrect
these
you from
other
the
ones,
dead
like
and turn you
medical
into a
isotopes,
radioactive,
the backbone of a lot of
nuclear
imaging
powered
techniques to
Jaeger.
find and
You
treat
get why I beat the
different
hell out of you
maladies.
with this stick.
Space is
You can do what
basically
it
a
does.
giant maelstrom of radiation, so you can both use it and have to shield
Well, if
it.
you like
We'll
D&D,
go over some
we
of the
actually
crazier
do
ways of
stick
shielding
theory,
space radiation.
where a guy gets out
Actually,
there for the
today,
melee
semiconductors,
on going against
the
nunchucks
way
and
that
broken
the
stick
MIT
inside of
reactor
here
made
with
about 60% of its
actions and
operating
spooky
budget until
distances come
recently
bust
was
you in
by
the balls
irradiating
right here, and you'd be
crystals
like,
of
ow,
silicon,
look at
single
it, and you'd be
crystal
like, ow.
pools or ingots of silicon to make what's called an N-type semiconductor via the following reaction. If I can
You were
find
doing
the
good. I guess stable enough before you hit yourself in the nuts with the photon that is the
I'm
stick,
going to use the shorthand
and
that we
you
talked about last
glue.
time.
You enriched
Normally you would
yourself
take
with angular momentum and the potential
silicon,
momentum.
and you add a neutron,
We all laughed.
and you end up
It was funny. We
forming
burned that marshmallow.
phosphorus.
Ripples on the
I've not
pond.
memorized the
Went into
gases
the
of
air.
isotopes,
Kind
but
of
in the end,
didn't exist as
this is
much
actually
until
a
somebody
neutron
brought it out.
capture
The wave
reaction and then a
function became
resulting
congruent
decay,
at the Last
which
Supper there.
produces phosphorus, which is what's also known
Peter
as an
Cottontail
N-type
dropping
dopant.
combos, right?
It's a sort of extra negative, what is it, a negative charge type dopant that changes the conductivity of the semiconductor. There's lots of different ways of doping semiconductors. One of the
Takes
best
a
and
long
most
time.
uniform is to stick
You'll be
things in a
going.
reactor. So back when silicon ingots were smaller, like 4 or 6 inches in diameter, there was a constant train of these things traveling through the
Mathematically,
reactor,
they can prove it.
getting
Not
irradiated
all of
and
you,
being sold
counting
and
scattering.
cut up
Some of
into
you will
wafers
run
in
around
different
in here and
places.
do other things, but you will
And
do
it used to
this.
be
It's
students or
you
Europe
will.
jobs to load and unload those things from the reactor. Now, it's not that dangerous. As long as you use the right handling procedures, like put them on a cart, hold the
Look at that
cart
danger
at
noodle
arm's
just as
length and
straight.
push like that,
Do what you tell
your
it.
dose is
Look at
very
it.
low. And that's because for a given point source emitter, the dose you receive drops off as 1 over r, or the distance squared, which means that your arm's length, let's say your arm is about a meter,
Becomes
you
an
can
arbitrary.
drop the dose by
Roman
quite
foot.
a bit compared
My
to what's called
foot.
the
If we
contact
get those
dose.
numbers down
Well, this
wrong,
poor fool held the silicon
it
ingots
can.
up
You
to their
could
chest like
say that
They
the
were okay.
reaction
They
is
got
nuclear.
about 10 months of their
But in the
yearly
same
allowable
way,
radiation
time
dose
space leads
that
to
won't
different
induce any
elements
additional risk
having
of
different
cancer.
radioactivity
But to ensure that they would
through.
not exceed that allowable
He's going to
dose,
give you a better
they
line, but I'm
became
going
the
to tell you
administrative
Penn's
assistant for
row.
the reactor for the next 10 months. So their job in the
White
reactor
hole,
was to answer
black
the phone,
hole, things
not
that
a
still
radioactive
scatter
activity,
a spectrum
including at the
of
reactor.
what those M2, M1
Earth's
arbiters.
nuclear power, the
We
reason
just
why
did one
I
a
know
second
a
ago. It
number
was
of
a
you
real
guys
good
are
little
here,
clip.
is pretty simple. It's just a hot bucket of water. The way we make that bucket of water hot is by putting uranium or other fuel into these
So you
rods,
have water in
assembling
front of
a
you
lot
all
of
the
them in a
time,
small space,
Mario.
where they then
Electricity
heat
in
up
itself
by
is
producing nuclear
the fuse
fission,
box and
capturing
grounding,
the
and
resultant kinetic
the
energy of
Mario
fission
water
products
works
and
for
neutrons and everything else that
congruency
comes out,
before the rip
and
roots
using
off
it
in
to either
Bernoulli's
heat up
house.
or boil water that's then just driven through a heat exchanger
Is a yellow cake
and a
factory,
turbine.
maybe
So
thermal,
aside from everything on this side,
was it thorium
it
nuclear
looks
salt
basically
reactors?
like any other water
You know, I mean,
power
but
plant.
you have it all
Difference
around
is
you.
things get
Air
toasty in a
molecules and wave
radioactive sense,
functions and
but
turning
also pretty
chemistry
well
into
under
the stuff
control.
you need out of
And what's
coffee or
inside a
get
reactor,
caffeine and
if you say this is
get
the
loaded for the
diagram
pin
of a
chip
typical
configuration of
pressurized water reactor, or
your
PWR,
reactor today,
where the
and
water
these
is
areas
pressurized
right
enough
here
so
are
as
pretty
to
hot,
stop boiling
and
from
they getting
occurring,
real hot, and that
keeping the water
offsets
liquid,
this in a
which is-
pure
has a number of
state
safety
that turns them into
implications.
steam.
You've
That
got
turns
the
a
core of the reactor
turbine
right here,
that does a thing
and these things
on a
right here are
stretched
called
out
steam generators.
timeline
It's nothing more
for
than
the
a heat exchanger that
housing
generates steam.
on that
And the
system,
steam generated in here goes off somewhere
and that's how
else
that's how
and drives the
radiation
turbine.
you
If you look inside this
You
reactor, you'll notice
use
a lot of
technology.
different fuel assemblies or